right, we got a few seconds. I'll put myself on mute and have a great broadcast.
Thanks, Jade. All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great event on tap. I'm very excited about this when we have a demo, and I'm all about the demos myself. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of it, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your question and answer interface there on your big marker interface. And we'll try to get to as many questions as we can near the end of today's webinar. We also have a very public chat feature, so if you want to chat us up, we'll be more than happy to take your questions, comments, suggestions, whatever you want to share with us. We'll be more than happy to chat you up, and you can chat us back. We also, at the end of today's webinar, are going to be doing a drawing for 4 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is comparing OpenShift, Istio, and NeuVector Egress security controls. Our speakers today are Tracy Walker, who is a Senior Solutions Engineer at NeuVector, and Cameron Skidmore, who is a Global ISV Partner Solution Architect at Red Hat. Gentlemen, thank you so much for joining me today. How are you?
Very good, Charlene.
Doing
Excellent.
good. Glad to be here.
All right. Well, Cameron, I know you're going to kick off the conversation with a polling question, right?
Yeah, very, very important polling question. I need everybody to respond to this polling question. It's very important you do. So let's go ahead and pull that out.
All right. The polling question is now open.
Yeah.
Do you see the
one correct answer.
All right. The question is, what is your favorite carryout food? And anybody who is hungry at the moment, such as myself, should be able to answer this question very quickly. Yeah, we've gotten lots of responses in so far. So Cameron, I don't know how long you want me to leave this one poll open, but I'll leave it open as long as you want, and then we can move on to another polling question that we have, which is a little less, little closer to the topic, shall we say? So.
Yeah. Well, the correct answer was Thai food, and tonight is Thai food in my place, and I will not humbly disagree with anybody who did not pick Thai food or won't. Yeah, I think we can move on to the next polling question. Right. I'm curious to see.
Do you want to know the answers to this polling question? So, because
I would love to actually.
Yeah. So
I would like to know what Tracy.
the largest percentage of folks said pizza, 35%. But here's interesting. The second largest number of people, 30%, said, I cook my own meals. Thank you very much. So,
well, those people will not be getting a ring from DoorDash in the next 5 minutes.
If they do, they should charitably give it to somebody else. Exactly.
Yeah, right. So Thai food came in at 22%. So followed by tacos, burritos, and Chinese food.
Okay, well, fair enough. That's understandable. Everybody likes za, so I can understand why the pizza might have won. But yeah, let's rock on over to our next poll question.
Okay, it's open now. And the question is, what kind of Kubernetes are you running in your environments? You can choose from vanilla Kubernetes, cloud native, EKS or equivalent, Rancher, OpenShift, or Kubernetes. What is that? Some kind of fancy Rubik's Cube. So go ahead and make your choice. Cameron, I don't know if you want to kind of start your conversation a little bit, and then we can circle back on the answers if you want, or we can just wait for the audience to make their choices.
Sure. I think we can kind of start chatting a little bit. I mean, Kubernetes is becoming the future of all infrastructures one way or another. It's really about what your journey to get there is, and then even once you get there, right? What are you going to do to make sure that you're on top of everything from a development standpoint, making sure you're creating value as quickly as possible, but also from a security standpoint. And we're going to look very closely at how to integrate that at every point of your journey to Kubernetes. So if you're, dyed in the wool, I was part of Kubernetes when it was in alpha, or if you are new to the idea, I think you're going to learn a lot. I think you're going to come away with an appreciation for a lot of the work that has been done for Kubernetes over the last couple of years.
All right, I'm going to go ahead and close the poll here. We'll take a quick look at the results. The question was, what kind of Kubernetes are you running in your environments? Actually, the largest number of folks said that they are running OpenShift. And then that was 29%, and that was followed by 25% each said either vanilla Kubernetes or the fancy Rubik's Cube kind. And then, and then we had 18% who said cloud native EKS or equivalent, and 4% said Rancher. So those are some really telling. And just a quick aside, just a quick check of the public chat. We've got some very hungry audience members, so we may have an insurrection before the end of the webinar if we don't get them food soon. But listen, guys, I'm going to take myself off camera, put myself on mute, and let you guys go on with your presentation.
Thank you so much. All right,
Thank
Tracy, you want to dive in?
Absolutely. So, we're going, there's a lot of security issues that we could talk about, and especially when we're talking about orchestrators, microservice deployments, and things like that. And it's certainly fascinating to watch from this side as we talk to different prospects and customers about their journey, because every IT environment is different, is unique, and every journey can also be a little bit unique. And so it is fascinating to see where companies are. Sometimes they're moving straight to OpenShift. Sometimes they've grown Docker containers that they've been running in the cloud, but now they're starting to feel the pains of trying to orchestrate and do health checks on all those kind of things. And that's where, yes, having a microservice orchestrator comes in. So we'll talk a little bit about, yes, there's lots of places where you can have, where you're trying to protect and apply security. For example, preventing vulnerabilities from getting into your pipeline, either through modules or packages or libraries or things like that. Things that you can scan for, right? Vulnerability scanning. Misconfiguration, making sure that the standard best practices are being followed for, setting your settings in either your platform or even within the container. So here, scanning for like CIS benchmarks for Docker, Kubernetes, OpenShift has their CIS inspired benchmarks, which you should be using. Probably most importantly, even, obviously we're going to focus a little bit here on security within these kind of environments, but as Cameron mentioned, the whole point of this is speed, right? We're trying to deliver value to the business as quickly as possible. Software development is one of the most complex things you can do in a business. It's the highest risk thing you can do, right? In a business, because failures do happen. These are complex projects with lots of moving parts and pieces. You don't want to slow that down, particularly in the name of security, right? You want to have as much security as you can have without hampering or slowing down the velocity of your software development lifecycle. And then, of course, as customers or as companies get into these environments, they begin to realize that while they offer lots of advantages, these are new attack surfaces that are inside of these clusters. We like to say it's like having a database or a data center inside of a data center, right? Because you can expose your applications and services from within these clusters that traditional environments, there were lots of parts and pieces that you may have as perimeter firewalls and load balancers and things like that. But now if it's in a cloud environment, cloud provider could be taking care of a lot of that. But nonetheless, inside of these environments, you have a lot of this communication happening and these new attack surfaces, applications running inside the cluster, container escapes, network injection type of attacks, those kind of things. So, and which I was just talking about, application kinds of attacks. So yes, so the real point of all of this is really what we wanted to do is kind of scope down to egress, because we kind of felt that this was a great way to, it's kind of a realistic use case for one. Also, it's a great way to kind of compare for a specific use case the different levels of security that you might want to implement. And quick point, none of these we're saying are bad, right? So we're going to compare these, and there's certainly, there's always trade-offs, right, between different things that we can do with different technologies. But the most important thing you can do is do some risk assessment of your environment and apply something, right? Something is better than nothing. And also, we're not looking to put $1,000 bike lock on $100 bicycle, right? Your security should be applicable to the environment and what you're trying to protect and the sensitivity of that information. And the last point I'll make is we picked egress control also because it's also kind of the last thing people tend to focus on in security. There's a lot of focus on accessing and role-based access control and preventing someone from getting access. And then we kind of really focus on all of that, and we don't always necessarily focus on, well, sometimes it's handy to know how they're leaving with the information. If they got through all of those things, this may be your last chance to prevent them from leaving the store, so to speak. So that becomes very important. And so we'll just leave it at that. So we're going to focus on egress control. And just as a quick summary, what is egress control? Well, it is connections outside of the cluster. Now, technically specific here for OpenShift, we're talking about outside of a project. For Kubernetes, it's outside of a namespace, so some nomenclature there. But yes, we're talking about essentially outside of the cluster. Limiting the potential breaches and attacks. This is how someone is making off with the data. If you had a way to prevent it, if everything failed, but the last thing may be worth putting some effort into as far as limiting egress and things like that. Very handy when we're talking about things like reverse shells, struts attacks and things where, someone is trying to get access to an environment and get that reverse shell where they can execute commands and things like that, or crypto mining as some of our favorite electric car companies have experienced firsthand. Lots of hidden stuff there that people are Googling right now. Yeah. Some of the challenges, source IPs can change because, again, these are kind of ephemeral environments. They scale up and down. You can add worker nodes, you can add pods, you can scale this in lots of different ways. That becomes very difficult for traditional firewalls and gateways because those IP addresses can change. And if their permission rules or firewall rules are focused on a single IP and those are changing all the time, then that's going to be a little bit of a challenge. And we'll talk a little bit about container gateways, but you can use some gateways inside of a cluster with things like Istio. We'll touch on that as well. And from that can also be a bottleneck or performance concern. So again, some of the trade-offs that we're talking about, things you gain versus the trade-offs for that. So with that, let's start with kind of the basics in Kubernetes. So a quick overview. First of all, you have to be using a supported CNI plugin, and that plugin has to be turned on, right? So I believe that the default is that pods can communicate openly until you turn on or use at least one network policy. So once you use that policy, then everything gets turned off, and now you can start to use some of that egress control. So yeah, the default is all pods can egress the cluster. And then once that's enforced, you can then create some egress controls based on a destination IP address or ports, and you can then block all egress controls. That will be namespace based. So yes, can support IP and ports. So that's going to be layer 3, layer 4 protection. And then, of course, we're talking about a namespace here. So some details here. So this is going to be allow rules only. The way I commonly see customers using this is they're using Kubernetes network security policies. They're defining those in development. And basically, these are the allow rules that they're setting up for layer 3, layer 4 ports, protocols, layer 3 protocols, TCP, DNS, et cetera, HTTP, HTTPS. And not really an external outside of the cluster. And this is really kind of focusing on, you have to specifically allow connections outside of the namespace, but then separately to specific services. There's no concept of rule prioritization. So if you're familiar with kind of typical firewalls where you have ordered rules, and then as soon as you hit a rule, it takes effect, and higher priority rules take effect before lower priority rules, you won't get that kind of prioritization using the native Kubernetes network security policies. Also, and there is no hostname or DNS support, which is probably, I think that might end up being the biggest pain, is that it doesn't support that DNS or hostname support, which makes it a lot easier, especially if you're trying to prevent egress to certain IP addresses or IP blocks, and they're changing all the time. It certainly makes it a lot less management overhead if you can just use a DNS name and not have to worry about the IP addresses underneath that.
Right.
Cameron, any thoughts or questions on this so far?
Just what you just said about the DNS, it kind of hits to the point where Kubernetes is the foundation for so much, but there's a return on investment for the effort you have to put into Kubernetes to make your own tools to make it work the way specifically you want it to work. And as you scale up to the enterprise level, that becomes more and more unwieldy. So that's why you're going to see a little bit later on why Kubernetes alone, good for a home lab probably, for the enterprise, and getting the most out of both your infrastructure and your employees, the engineers working on it, probably not the best choice alone.
Agreed. And not to mention the policy example that we're looking at right there. Unless you're using a commercial product that can suggest these kind of rules, other than that, you have to create these manually. So
right.
There is time and effort for even doing that within a development environment. Well said. Let's move to our next example, Istio. Very popular service mesh. We see it everywhere with customers. The example that we're showing here, this kubectl, it's basically doing an apply of this type of egress service entry. And even as you kind of look at it here, you can see the ports where we're talking about 443, HTTPS, and resolution. So this is, and as if you aren't aware, Istio uses a sidecar architecture. So basically for every container, there is a sidecar proxy that is affiliated with that container. So you will double a little bit of your infrastructure. Is basically for every container, you'll have a sidecar, and that sidecar is going to handle all of the network connections and things like that. And so that is kind of what we're talking about here. Does support DNS, which is great, as well as HTTP and HTTPS. So there is a limitation on the protocols that can be routed to those sidecars. In fact, you can allows a bypass. So you can do a bypass from those proxies for specific IP ranges, and you can also use an egress gateway. So this is what I was mentioning earlier, where you can set up an egress gateway, and then all egress traffic would use that gateway. So that's one way of kind of controlling that. Where that could be, as you can think of, you are literally creating a bottleneck there. Doesn't always mean it's going to be a bottleneck. It's just something you have to kind of remember if after deploying Istio and you see some performance changes, these are the kind of things that will cause those changes. Details of note. So no application protocol verification. So what this means is that there is no network inspection or deep packet inspection happening at the network level. So it's not looking at, say, above layer 4 for application protocols that it can identify or validate. That would be an additional thing of security that you can do because that sidecar proxy isn't considered necessarily concerned. It can be bypassed. In fact, for the types of layer 3 protocols, they support DNS, HTTPS, HTTP, but for protocols that they don't support, they can't guarantee that it's going to use that sidecar. You can add Kubernetes network security policies to help make sure that everything uses that sidecar. So you would need to use kind of a combination of Istio and Kubernetes network security policies, or the products that we're about to talk about. You can also use those to accomplish that.
Yeah, and already, Tracy, we're creating a narrative here from the very beginning with Kubernetes, and then orders of magnitude incremental improvements as we go along. So Istio itself, huge improvement over Kubernetes flat out. But again, there's more and more and more that you'll want as you scale to an enterprise level critical applications. So we're getting into that.
Absolutely. And also another great point, you just kind of triggered the thought in my mind, Cameron. Istio is, as a service mesh, is focused on service availability, connecting services within the cluster and things like that. So security is not the very first thing we think of with Istio. We're really thinking of making it easier to deploy and make services accessible, and letting Istio kind of handle some of those complexities for us. So there's certainly some security features in Istio, but not always. Sometimes I will caution people to think of it as strictly a security tool, because I don't know that that's necessarily its first and foremost function and use case of why you would want to use that. You can do things like TLS between the sidecars, things like that. So there's certainly some security features, but its real focus and use case is maybe not 100% security.
Right. And in many ways, I think a lot of the value of Istio is getting more value from your developers. It does relieve some burdens on developers. So when we talk about driving value from the Kubernetes environment, what we're really talking about is driving more development. And as we go on, you're right, Istio itself, maybe not security is the first thing in mind, but it does do a good job of driving more value from a developer standpoint. But security is inseparable from the product, right? Your product is the security that you're baking into it. So it's best to think of the value add there in the same exact way, I think. Absolutely.
And what a fantastic segue.
Yeah, I think it's time for me to get on my soapbox about OpenShift. But thanks, Tracy. I'm having a great time already. I'm just going to give a quick rundown of OpenShift. I'm sure a lot of you are already using OpenShift, it sounds like. So you kind of know what's up already. But in order to set up kind of some of the conversations we're going to have, I just want to briefly touch upon it. So the first thing I really want to talk about is, and remind people of who may not know already, is OpenShift is Kubernetes. It's just more than just Kubernetes, though. So whenever you think of OpenShift, know that your foundation for OpenShift is really that trusted open source Kubernetes platform. In many ways, OpenShift is a smarter Kubernetes platform because we've streamlined the installation and upgrade experience. And when you're dealing with environments, modern environments like Kubernetes, installation upgrades aren't just an inconvenience. They are, but it's also about freeing up more time, right? Freeing up more time for your administrators and your developers. You can be up and running with a fully configured Kubernetes cluster in less than 15 minutes with OpenShift. And you have everything you need from day one with the monitoring at the cluster level, and then also to the application and developer services that they're going to need to create value. When it comes to Kubernetes updates, security patches, and component updates, they can all be deployed with a single click. Again, you have some smart people on your team. They could probably figure it out, but it's just such a time save, and time really is value and money. And so we're trying to, lower that technical barrier to entry, but also create greater efficiency with the services and tools that we're adding on top of Kubernetes with OpenShift. Speaking of creating value and really taking the complexity and making it a little bit more accessible and streamlined, Kubernetes is relying on a foundation of RHEL and Core OS when it comes to OpenShift. This means OpenShift can actually update the underlying operating system and scale at a node level, which is particularly useful when it comes to deploying OpenShift on cloud infrastructures, because the entire cluster can scale up and down based on the application needs. And what you get at with CoreOS combined with OpenShift is bringing it all within one house in a way. You're allowed to manage, scale, update, do all these things in a very proficient way. And it helps your teams out, but it also helps you get to scale very quickly. Speaking of all those services, Tracy, do you want to pop over our next slide?
Sure. Sorry, I jumped to it a little early there.
Oh, no, you're fine. No, you're good. So yeah, when it comes to security, I think we talked about this before, but security is also part of the product that you're creating when you're creating your software for your customers. Static security policies and checklists are really no longer going to cut it, and they don't scale for containers in the enterprise. To really get the business advantages of containers, enterprises need to evolve their approach to security. And security has to be this continual process of the enterprise, and it has to be baked in at every step along the way. So you need it not just in practice to be baked into all these different parts of your platform, but you need everybody in your company to also be thinking about it. You can do this right. You just have to plan for it, and you have to have the tools ready to use it. Securing containers is a lot like securing any running process in your environment. You need to think about security throughout the layers of the solution stack before you deploy and run your containers. You also need to think about security throughout the application and container lifecycle. We've got some really cool stuff on that later where you can kind of visualize out that entire lifecycle. There's a lot of complexity there, but the theme of this is taking complexity and making it very accessible for people to get going. And then these three main points here: you need to control the security of your containerized apps. You need to defend your container platform infrastructure and extend the security of your overall solution by leveraging the tools from our broader partner ecosystem. That's why I'm excited to be here today with NeuVector, because they're such a wonderful example of how we work with our partners to execute on that focus of extending everything out. They do that, and we do that with the NeuVector Certified Operator, which Tracy, I think you might have one slide. Yep, we're right there. Boom. For that. And when it comes to the certified operators for OpenShift, they live in our operator hub. That's how you'd access it. It provides a single place for developers to publish their operators and for customers to find and consume their curated operators there. So if you just go there right now, these operators meet a certain quality standards, and you can have a lot of confidence that what they promise is going to be delivered. And you can deploy these operators on any Kubernetes distribution, not just OpenShift. But we've also integrated Operator Hub into OpenShift, where you can find these certified operators like NeuVectors from our partners that meet an even higher bar of quality standards. Not only that, but you can also count on the joint support between both Red Hat and our partner, like NeuVector, in order to support that. So that's another aspect of getting enterprise ready that often comes up, is that you need to know that the software you're using has the backing of a true open source company behind it, and a true software company behind it. And that's what you'll get with with our certified operators, is that backing and security. But that's a brief overview, a blitz of all that. So Tracy, I think we're on our progression of magnitudes of improvement. So let's keep that going.
Absolutely. Yeah. So, so egress control using OpenShift. This example, this egress network policy, great example of a custom resource definition, or CRD, where Kubernetes allows vendors such as Red Hat and NeuVector to extend the Kubernetes API to do the cool things like you're seeing here on this type of egress network policy done within OpenShift. So this would restrict egress outside of the cluster, would support one network policy per namespace, and will support hostname DNS, also supports deny rules. You can set the ports as well, so you can kind of, that's all fantastic. Rule ordering is based on the order of definition. So when you're doing these definitions, just as you're seeing here, that's where that rule order is set up and will be followed. A few details to note about the OpenShift network policies or egress network policies. It won't, we're assuming in this that we're not using the OpenShift service mesh. And not to catch you off guard here, Cameron, but is the service mesh, OpenShift service mesh, is that default, or do you have to set that when you're doing the deploy?
I believe you have to set that when you're doing the deploy.
I see.
But it's the same kind of concept. Istio being the open source project, we then support that, and we out of the box make it a little bit more approachable.
Got it. Is unlike Kubernetes, there are no pod selectors. In Kubernetes, you can do namespace and pod selectors, but in OpenShift, you would do a namespace, but you can do that without pod selectors. And in both Kubernetes and OpenShift, there really isn't a ability to verify the application protocol at layer 7 for egress. That is another layer of security. That's where we can validate the protocol and look for like tunneling attacks and things in the network stream itself. And so that is also not there. So in kind of speaking to that, and I'll just kind of click through these to get all of the different kind of egress control wish list. So if we were looking for advanced egress control, we kind of start to veer into, security products kind of focused on security specifically, where you would be able to do multi-protocol, be able to use CIDRs, hostname, DNS. This application protocol verification is particularly important because that's almost an entire layer of security unto itself, right? We could talk about allowing a network connection or allowing a process to happen, but if we're able to detect something in that network stream that doesn't match the protocol, I think I mentioned the struts attack earlier, but any kind of SQL injection, struts attack, anything that somebody may try to put into that network stream when a website is exposed to the internet or those kind of things, that can become another layer, because if you can detect that tunneling attack or that embedded whatever it is in that application protocol, and that makes that protocol essentially invalid, that's a great way to say, no, I don't want to allow that network connection just because of the way it's bringing some data or it's bringing something, and infiltrating in through that network connection. So that is particularly important. DPI, so the Deep Packet Inspection, Payload Inspection. So this actually has more to do when we're talking about egress and we're talking about payload inspection. We're really talking about data loss prevention, being able to look at the network stream that's leaving before it leaves your cluster to see, is there anything in this data that I don't want leaving, like a credit card number or social security number or any kind of PII data, or if you have data sovereignty issues or rules, that regulations that you have to meet. We have a number of SOC 2 company customers that have SOC 2 regulations and had to have data loss protection on their new OpenShift environments because they needed something that matched that SOC 2 requirement for data loss protection. So that would be a big deal. Flexible between monitor and blocking modes. So we're kind of taking this from, like, say, some of the firewall capabilities of being able to create a zero trust environment. It's to create a zero trust environment and then just to simply block everything may not work in certain environments. So the ability to create zero trust, monitor known connections and known processes, and then be able to filter out and see any anomalous behavior, any anomalous network detections that aren't part of your normal behavior of your application or of your environment. So being able to create that zero trust almost requires a monitor versus protection mode, so that you can turn on zero trust and then see, did you capture everything? Do you have all your rules appropriately built? Those kind of things. So that kind of flexibility of being able to not necessarily turn the security all the way on to protect mode where you're blocking things, but to have that flexibility of using blocking for high sensitive, high security parts, services, databases, whatever it may be, and then maybe monitor where you still have zero trust segmentation, and you can see the differences there. And then full logging, alerting, packet captures, these are really more security focused kind of, looking for that anomalous behavior, sending alerts for that, doing an automatic packet capture inside of your cluster of what's going on. Some of these kind of post-event inspection and investigation, really those kind of tools. Countermeasures to something that you're seeing, being able to block connections, being able to quarantine containers that seem to be either vulnerable or behaving in a way that seems like there may be something going on. Somebody's coming in doing some kind of container escape, that kind of thing. So you need that from a tool that's alerting you to those kind of things. And then finally, the ability to do rule management, make that very easy, maybe hopefully so that you're not having to do that manually in YAML files. Nice UI, those kind of things, or even automatic via API. So these would be a nice wish list. And I made this wish list partly because this is a lot of the things that NeuVector is able to do. We do base our rules on IP. We are able to inspect application protocol. I'll just quickly kind of go through a few of these to highlight. We support multiple protocols. We actually support like 34 different types of application protocols, from Oracle, MySQL, Redis, etc. So we can identify protocols within that network traffic as well as validate that protocol so that we can see those tunneling attacks. So that I was talking about earlier, that extra layer of security that basically says if it's a valid protocol, all good. If we see some kind of SQL injection, struts injection, et cetera, in that payload, we can stop it there. Granular rules, a lot of the time, the more you get granular, the more management overhead that comes with that. And so often we find users are trying to find that happy balance between what's granular enough for security, but yet is low enough overhead that I don't have to maintain it all and change it every time something changes and those kind of things. So it would be even better if, NeuVector is able to build these rules automatically because we have behavioral learning, because we're able to use our deep packet inspection to see the network traffic inside of the clusters. In fact, if there's one unique feature that NeuVector brings to the industry and to security and to OpenShift environments, is that we are able to inspect the network traffic inside of the cluster. That is our big differentiator. We don't use like eBPF. We're not using like syscall filtering to identify layer 3, layer 4 syscall commands, the send and receive commands happening on the worker node. We're actually inspecting the network traffic inside of the cluster. We can see the traffic, we can see the connections. We're not using sidecars or agents. Our deployment is pure Kubernetes, OpenShift native containers. And we have some patents around our ability to look at that network traffic and to see what's happening real time, and then to be able to base rules on those, on that behavior. And extensible with DPI, deep packet inspection, that data loss protection I was mentioning earlier. Yes, because we see the network traffic, because we're using the network traffic as our source of truth. We trust that we understand what we're seeing there. That's how we're able to validate those protocols. That's how we're able to do that data loss protection on the egress, that we can see that network traffic that's leaving. We can even see if you were using Istio, we don't conflict with Istio. We don't conflict with network security policies. So if you've already invested the time in building those policies, you can continue to use those. The analogy I like to use with that is, if your developers have spent the time locking the doors for your data center using Kubernetes security policies, it's still good to have a camera on those doors, because again, if you don't know that you can guarantee all traffic will flow through that sidecar proxy, you need rules that will do that. So you can do those rules in Kubernetes security policies. You can do them with NeuVector as well. And we will monitor to make sure nothing else is using anything except that sidecar proxy. So we can enforce the security around that and make sure that all traffic does use that sidecar. And even if you're doing the TLS inspection, one of our pending patents is because we can see the traffic before it goes to the sidecar when it's encrypted, then it gets decrypted by the other sidecar. We see the traffic on either side of that. We don't decrypt that traffic between the sidecars, but we can see the traffic coming in and going out of those sidecars. So again, no worries if you want to use NeuVector and Istio along with OpenShift and OpenShift security policies. We will not conflict with those. We will help you enforce them and monitor them and know that they're working as you wanted them to. So very quickly, I'll give a couple of quick examples because I'm watching the clock. So direct connections to external host name, pretty straightforward. And this example too, all traffic must go through a SQUID proxy. So being able to block access to certain domains, like you can see here, blocking access to like an Oracle domain versus allowing something to Morningstar. So that kind of granular egress controls there. And one of the more interesting examples, I think, is security requirements where you may have a mix of OpenShift clusters, services connecting to more legacy services or databases or whatever the case may be. They're maybe on VMs behind a firewall or in a cloud environment. So in that case, the problem is usually you are not able to do that kind of granular firewall rules at the firewall, right? You would have permission rules to allow everything to talk to that VM, right? Or maybe specific protocols. We can define granular egress rules at the cluster level that would say this service must talk to this service in the green on premise or whatever the case may be, and make those more direct so that you don't have to worry about connections being allowed between different services, that can go to the wrong part. I mentioned a little bit about the DLP, basically, just to kind of restate what I was talking about before, the ability to do data loss protection on the egress from the cluster where we're actually looking at the payload of the network traffic for anything that might contain sensitive information. Usually this is done inside of the cluster where you've created a group. We won't check the egress of a specific container. What we want to look at is the egress from that group. So it could be an entire cluster or a group of containers that are sensitive where you may have that. We won't check the internal egress between pods or within the cluster itself, but anything that leaves as an egress outside of that cluster, yep, we'll check that payload and look for social security numbers, et cetera, and block those. So again, one of those last chance blocking efforts. If all else failed, this would help catch that. And again, if you're a SOC 2 company and you're running containers in a production environment, you are required to have DLP per SOC 2. And NeuVector can give you that DLP inside of those clusters. We can, NeuVector, last thing I'll touch on, and then I'll kind of show this in the application itself. And we'll just kind of do a really quick 5-minute preview. You'll notice that we're doing NV security rules. So that is a custom resource definition, much like OpenShift is using. Here you will notice additional points within this YAML file for egress. So you can see the criteria allowing for protocol as well as ports. We also do file protection. So we can protect file locations within a container. We're natively already protecting kind of sensitive locations like Etsy password, user local bin, Etsy host, those. We already take care of those. So you don't have to set those kind of things up. But if you want to add additional file protection, you can do so. Egress rules and all processes. So you'll notice that this is not just a network security policy. It's also process security policies, processes that we have learned as part of our discovery of what processes run on every single container. So we can turn those into allow rules. You can edit these files, make them deny, but this will be based on the behavior that we have seen firsthand. We use the processes, or we collect the processes that are running on containers, and we collect all of the network connections every container makes. And we're using the network as our source of truth. That's how we're able to know that we trust that data. We know what that layer 7 protocol is if it's available. And we trust every network connection that we see, as far as knowing that that was a network connection. We know from looking at that network traffic.
Really cool stuff, Tracy. I think that's a really good breakdown slide. So fun time, right? Time for the demo?
Good times.
Good times.
Yeah.
Sorry for my echo there. Yeah, so this will be very quick. So what you're seeing here on this screen, this network activity screen, this is actual network traffic, and it's a live snapshot in time of network traffic. Every time I refresh, it will update. You'll see a lot of blue lines here. So these blue lines, we have 3 modes. We have a discover mode where we learn the behavior at the network process and file access level. Then we have a monitor mode. So when you switch one of these containers, and if I right click on one of these, you see the discover, monitor, and protect. So that monitor mode, when you move to that, that creates a zero trust microsegmentation just by moving to monitor mode. Basically, we won't learn anymore. We have our baseline of network activity and processes. And so from that point on, we will alert you when we see something we haven't seen before at a network process level. And also we will, we're going to alert you. We won't block it. It's completely safe, but this is your first step to doing zero trust. Then this protect mode allows you to not only get alerts on anomalous activity, but also block it. So you can block at the network level, you can block at the process level. There's lots of ways of setting up how you want your rules to work there. You can also see up here at the top, we can do things like packet capture inside of the cluster. We will do an automatic packet capture if we see one of those aforementioned 34 or 30-ish different network threats that we can look at. So we can do automatic packet capture when we see those. You can do quarantine without killing, some of those things. And then the last thing I'll show very briefly is the example of that security as code. So knowing firsthand kind of the pain sometimes it can be to create those YAML files and get them accurate, that does take time. In this case, you wouldn't have to do that. You'll notice I've got all of these containers in this demo namespace. And as I click down here, you can see process profile rules. I even have a deny rule. So this would be user created, a deny rule where I basically said, you know what, we're not going to allow curl on that container. And also the network rules that we've learned as part of that discover mode. You can see application protocols like Redis and MySQL there. So not only layer 3 TCP DNS type protocols, but also application protocols at layer 7 where we're validating that protocol there. So we've done that for all of these containers. I can do this via the API and make it automatic when I push my new namespace to my registry. But here, just as an example, see this export group policy. I'm going to export my security policies for all of these containers, and I can even change the mode, the operational mode that I want to deploy these rules to another cluster. So this becomes that security as code where we can export that YAML file, and I don't have to create it by hand. It will just as that loads here, there we go. So you can see we create that automatically. So again, if you spent time creating those YAML files, that's awesome. But this will give you a way to verify those, fill in any holes that you may have, and you can do this across all of those different containers. And then you can apply this using a kubectl apply -f of this file to a different cluster, and we will place those rules on that different cluster. So you can take the rules from development to QA to staging to prod and make that part of your pipeline. So that's another fancier automated way of doing more egress, where you can have that defined or at least validated and monitored to make sure nothing else is doing an egress.
right? Not that people might not be, especially engineers, might not be able to create their own YAML, but it's just automating that process just saves so much time. And if the automation also frees you from inevitably making an error once or twice, right? You can be perfect 99% of the time, but there's always going to be 1%. So it's just makes your life easier and less stressful.
Spot on, Cameron. So to highlight how OpenShift and NeuVector really give you coverage, yep, this is very busy. And I'll pause here for questions. I haven't paused enough to ask for questions, but if you have any questions about coverage, really what this is describing at a high level, you've kind of got your SDLC of building and testing, and then you have your categories of like compliance, network controls, data controls. Really what we're talking about here when you see SCA and SAST and image risk, we're talking about scanning at this point. We're doing analysis of all of the rules, you're doing the CIS benchmarks for configuration settings, you're scanning for vulnerabilities. And then you're also getting into like network visualization, policies, traffic controls, all of these things that you see as you get into a running environment, kind of the runtime security. So you can see between OpenShift and NeuVector, you get really nice coverage between all of those facets for security. Any questions or details on this? Because this is obviously may want to inquire about some details on this if you'd like.
Yeah. So we have I would say about 7 or 8 minutes for questions. So if you do have a question for either Tracy or Cameron, please go ahead and get it on in. We've gotten some questions in so far, so I do want to dive into the ones that we've gotten. Okay, what is the difference between deep packet inspection and eBPF?
Very good question. Thank you for paying attention. So eBPF is basically using Berkeley packet filtering. You're using a kernel shim, or you're inquiring of the kernel on the worker node, the host that's running underneath your OpenShift cluster, and you're collecting all of the processes that are happening there, as well as any network processes. So I'm stressing process there because at the kernel, you're getting processes running at the kernel of the host. You're not seeing network traffic on the host. You're only seeing the only 2 commands at the kernel that have anything to do with kernel with networking is send and receive. You're sending all the send and receive for the NICs on those hosts, right? But you're not seeing the network. You're not seeing the traffic or the payload. So that's the difference. The one is really kind of focusing on the processes at a layer 3, layer 4 level, and you're having to filter all of those out versus using the network as your source of truth, where you can do the deep packet inspection of identifying the layer 7 protocol, then validating what you identified to make sure that that protocol matches its definition. That's the deep packet inspection. Data loss protection requires that you would be able to see the network traffic. You're not seeing that at the kernel level. So that's the difference there. eBPF is a fantastic technology, works at the kernel level, great for tracing and performance tuning and being able to see everything that's happening at the kernel. It just kind of comes short when it comes to security at the network level, which is a little bit higher level or a different level than what you're seeing at the kernel.
Excellent. All right, great. Next question here. What parts of NeuVector security can be automated?
All of it.
All right.
All of it. Yeah, almost all of it, but yeah, all of it. Like the discovery mode is automated, so we can learn everything automatically. When you move to a monitor mode, we can export those policies automatically. You can apply them automatically. We have a couple of different ways of applying rules to multiple clusters. We can do federated clusters and have federated rules, or like I was showing the security as code, that doesn't require clusters to be able to see each other. So we can run in air-gapped environments and things like that, but all the scanning, everything within NeuVector can be completely automated. Yes.
All right, great. All right. Here's another one. Just came in, actually. So Jorn asks, if an organization has mistakenly engaged in a strategy that assumed Istio was a security tool, how difficult is it to untangle that and use these solutions alongside the service mesh?
I don't think you have to, untangle. Thank you for the question. I don't think you would have to necessarily untangle your service mesh because NeuVector would work alongside of that service mesh. Or if you're using the OpenShift service mesh and have that enabled, we're not going to interfere with that. Our architecture allows us to work within Kubernetes, so we're not using agents, we're not using sidecars, we're not altering your architecture whatsoever. We're just able to see that network traffic. So if you're using Istio, if you're using any kind of service mesh, we're cloud agnostic, we're CNI agnostic. So we really work with just about everything that you may already have in your OpenShift cluster. So you wouldn't have to untangle anything. Just deploy NeuVector in OpenShift and run with that. Cameron?
Yeah,
Cameron?
I would just add to that and say that's probably one of the more powerful aspects of NeuVector. It's there to support whatever you've got going on in that moment. It's not there to take the place of anything really. It's going to add an extra layer of security and control and automation to your environment, and that's really what I've come to love about it.
Awesome. All right. So we're about 5 minutes to the top of the hour, so I think we have enough time for one, maybe two more questions. So we'll just keep going on. Here's a good question. What do you mean by sources of truth? Isn't OpenShift Kubernetes or /Kubernetes a source of truth?
Yes, it is. Yes, you can have multiple sources of truth, right? In talking with like security professionals who do a lot of post-event investigation kind of thing, what we mean by sources of truth are, where am I getting the information and who said that information was accurate, right? So yes, you should be trying to get information from every source possible, right? You should be getting it from the Kubernetes OpenShift API, what the settings are, what the policies are, different things like that. But if you're only, for example, if you're only using eBPF or you're using a security tool that is focused on the processes and that they're collecting via eBPF, okay, so that's a secondary source of truth of what's happening at the network level, because you're only getting a limited amount of information like the layer 3, layer 4 protocol or port labels or what have you. You're not seeing the actual network traffic. You don't see any attempts to use different protocols or to do some kind of injection into the network stream or those kind of things, ICMP attacks, etc. Or DDoS. So using the network as a source of truth means that we're looking at the network traffic much like a security device would, versus other sources of truth where you may have limited information, or where really you're just trying to validate that the information is the same in both. Because if you saw network connections in NeuVector that you didn't see coming from the kernel, that's something to investigate, right? We're always looking for the clues of what's different and why is it different and what are they doing in here that makes it different.
All right. All right, great. Well, we're about 3 minutes to the top of the hour. So unfortunately, that's all the time that we have for the question and answer period. If we did not get to your questions, I think we got to all of them. But if we didn't, for some reason, I apologize. And please know that the folks at Red Hat and NeuVector are getting a copy of all the questions that came in, and I'm sure they'll be more than happy to follow up with you offline and get your question answered. Also, a quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following the webinar today, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always go look for it there. Just go to DevOps.com/webinars and look in the on-demand section, and it should be right there waiting for you. All right, before we close things out, I did promise at the top of the hour we'd be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's get to that. Our first winner today is Andrew S. Congratulations, Andrew. Our second winner today is Jim H. Congratulations, Jim. Our third winner today is Bianca P. Congratulations, Bianca. And our fourth and final winner is Stephen R. Congratulations, Stephen. We'll be following up with all four of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. Tracy Cameron, what a great presentation. Thank you so much for your information. It's, always, food related topics are always very well received by the audience. And so thanks for that fabulous poll to kick things off, but great stuff all the way around. Thank you so much for your time and your expertise.
Thank you.
Thank you.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.